I think the best in like Milwaukee is this Greeby's, and some gas stations down in like Milwaukee.
Like the glazed ones?
Yeah, they're so good.
I'm gonna have to go down there.
I feel like I should go down there this weekend and bring some back for you guys or something.
Yes.
Mr. Donnie.
Until last week.
Yeah.
But do it on
Next week.
Wednesday.
Oh, I was gonna say, well, going down on Sunday and then picking it up for Monday would make the most sense.
Everybody else.
We can save yours. I don't know how well.
Put it in like a little airtight container.
I know. I'm trying to think if like freezing it would be good and then defrosting it. I don't know. Cause I feel like Mr. Donahue's out of town this week. He's at a baseball coach's clinic, so like the boys and I need to do like a road trip. Like,
Well, I think if you put it in like a bag, it would be fine.
Not a bag.
Why not?
It's so good fresh though. Oh my gosh, it's so good.
Vacuum chamber.
And like us all eating in front of you just seems so cruel.
That's kind of nice choice.
Especially because on Tuesday I have to be 142.8.
And what are you now?
145. I'm 149.
Okay.
That's not bad.
Yeah.
Now we all feel like that's not that bad now that we've gone through this whole season with Stoked.
Yeah, but it's like
I mean, if you told me to lose 7 pounds right now, I'd like, I'd lose my mind.
This Monday, like we had to weigh in Tuesday, and this
Oh,
Monday
no.
I was like
To
6.5.
stress the people in the new weight
Oh
class.
yeah, we heard this already.
Yeah.
I think that's not happening. All right, so base 10 is the way we've always counted. So 0 through 9 is the 1 digit. And then once we go past 9, we have to add another like place value. So our normal counting is base 10. So like if you guys are talking about like 0 through 9, once you go to the next, it's kind of like you carry the 1 over. But the base in base 10 is a 10. So like when we talk about place value, they were talking about, they said like 10 to the 0, 10 to the first, 10 to the second. That tells us each place value. So the ones place is like the 10 to the 0 power. The tens place, so like 10 to the first would be like 20, 30, 40. 10 to the second would be like 200, 300, 400. So the base is 10. What they do in base 2 then is they change our base to 2. So this is the new counting we're going to talk about. And again, this is the way computers count or read. And it's the series or like a yes or no answer. The light is on or the light is off. So this is, it's basically 0 through 1. And what I have here is a little chart to help you guys kind of understand it a little bit better. And I think part of the idea with the base 2, again, also is that 2 to the 10th power isn't some crazy huge number. I mean, it's a big number, but it's not like crazy huge. So like 2 to the 0 is 1, 2 to the second is 2, 2 to the first is 2. So I'm doing my... Unless I skip something, I should double check with my calculator. 128. And now it can keep going. This is what I can fit on our page or whatever, within reason. So basically we can do numbers, not even up to 1024, but we can actually do numbers if we add all of these together. So again, that's what they're kind of talking about, like when I was a kid, like the Nintendo came out and that was 8-bit Nintendo. And it means they were only able to do like this much like coding there for those numbers, or 8, I guess it would have gone to. But then they got 16-bit Nintendo. That was a really big deal when that came out. Like that was like all the cool kids got that then. So kind of just like as a PlayStation, different values or levels of that come out, kind of same idea. So
No, the cool kids got Sega Genesis because Genesis does what Nintendo don't.
Oh, nice. And Sega Genesis came out with just the little guy for Sega Genesis. Sonic. Sonic was like the first like cool like Sega Genesis guy.
I'm very sure in terms of technical specs, like Sega Genesis, like blast processing and all that, meanwhile the Super Nintendo Entertainment System was geared more towards being able to display much more colors and all that. Although it's like, although really most of the marketing was like, well, our 16-bit machine is cooler because they dumbed and stuff. No, at least with Sega, it's just like, our 16-bit machine is cooler because Nintendo dumbed and all that. Nintendo's like, yo.
I don't know much about that. I didn't have a video game system for a long time. Alright, so guys, I'm going to do the examples here we have listed, so the examples 1 through 4 here. So the first one is 40, and I kind of gave us like a little space. Like I think this chart is kind of a good way to set this up. So I look at this chart, and I don't need anything bigger than 40. So the biggest number I need is I need a 32. So I need 32 because that goes into 40. So I still have an 8 left, right? Because minus 32 would be 8. So then I don't need a 16, but I need an 8. But then the other ones, like so 32 and 8 is 40, so these other ones become zeros. So 40 written in binary would be 1, 0, 1, 0, 0, 0. And you do need all the zeros at the end. So that would be 40. And so that, again, that doesn't seem super efficient, but again, it's better than tally marks. And also if we want a computer, like I could display that, like I could have this little series of lights sitting in front of you and you'd be able to read that number 40 versus I'd have to have 40 lights out here. I could have just 6 lights and I'd be able to represent 40 as that number. Okay, so then let's look at 129 here. And you guys might need a little more space when you're kind of like pulling those numbers out of there. Give you guys a second to try. And again, you shouldn't ever use a 2, so don't try to use a 2 at all, like always use a 1 or a 0. So 129, I'm going to go out to 128 because that's the first value that I would need. So I'm going to take 128 away and I'm going to be left with just 1. So that means all the rest of these end up being 0 all the way back to 1. So that's how we read that 128. Or 129, sorry. So we're going to get a little bit bigger here. And yeah, it's totally okay to pull out your calculator. I mean, even though it doesn't switch it over to binary for you, you're doing some subtraction and making sure that we don't mess something up with our subtraction with that. So our 397, I'm going to go out to 256. And then I'm going to take away 397 minus 256. And I have 141. So maybe I'll like write it this way. So now I'm at 141. So that means I need to use this digit as well, right? Take away 128 and I have 13. So I go out here, so these guys are all zeros. 13. Take away 8. So then I have 5. So I'll do a 4, and then I'm left with just 1. But you guys got the 397, if that makes sense. It's just another way of thinking. I mean, I kind of thought it was kind of cool once I played around with it a little bit. It scared me a little bit first, but then once I was comfortable with it. So then 34. Let's go up to 32. And then, so then I need just 2, and so then I don't need the 1 at all. Piece fell off my 3-hole punch, and I don't know where it came from. Must not be important. All right. So we okay with the converting to binary? Now we're gonna go the other way. Did you guys figure that out? I see some of you guys working further. So in having the chart up above, like maybe would be helpful as you guys are doing this, like that is helpful to you. So I'm kind of like, and almost like kind of working my way backwards maybe would be a smart idea. So like this first digit would be a 1. The next one would be a 2. Then I don't do any on the 8. Then I have a 16. Don't do anything on the 32. And then I have a 64. So you're kind of working your way backwards then, I think, if I did that right. Yeah. Did I miss something?
I think you skipped 4.
I skipped 4, thank you. So that's probably why I need to have it up in front of me. I don't have them like both on. Thank you for catching that. So let me just write out my powers. And yeah, that might be good just to have that written out. So our powers of 2, so like having all of those like written out above. So I'm gonna go backwards with this. Sorry, and again, this is, again, my first time with this stuff too, so I'm not super comfortable. Here's my 4. Okay. So we have 1 in this case. Maybe I'll work my way opposite. And then 2, we skip the 4. 32. Is that better? So do you get 43 for this one?
Yeah.
Okay. What was 111? 7. They actually, I think, did this one on the video when they were showing the apples. So again, not a very efficient way to write 7. But again, if you're talking about a series of lights or little switches, if we had to have 7 switches versus just having 3, it's more efficient in that way. And this last one's a little bit of a mess. There's quite a few numbers here. So we're gonna go plus 2, skip the 4, 8, 16, skip 32, 64, and 128. Is that it? I think that should be good. So I got 219 for this one. Is that what you guys got? Okay. All right, so flipping to the back side, I have to show you guys how to add with binary. And maybe you figured it out. It basically is like adding like by long, like the way you learned how to add when you were a little kid. Like if you're adding 526 plus 652, you're like adding, and once you get past 9, you carry the 1. Well, in this one, once we get past 1, we have to carry the 1, which is kind of strange. So, and then I'm going to have you guys kind of convert back to base 10 and make sure it makes sense. So, when we're adding, The minute we go over 1, we have to carry the 1. So 0 and 1 is just going to be 1. But 1 and 1 is technically, we're going to do a 0 and carry the 1. So we're going to go 0 and bring a 1 over for another place value. Then we have 2 1s together and then another 1. So that's going to be 1, but we have to carry that 1. Because it's over 1. There's 3, but then we have to move that digit over. And then again, we have more than 1, so 0, and then we're going to make that a 1. So this is our outcome when we add these. But again, I want to switch this back to base 10 to make sure it makes sense. Like, because when I was first doing this, I was like, really? That's all I do? And I want to make sure that that makes sense. So if we're talking about this number, this top number, well, the bottom number we just did was 7, right? That's 1, 1, and 1. So this is not a 1, so 2, 4, and 8. So is that 14? So if I add 14 and 7, it should be 21. So we're going to check that. So here's our 1, 2, 4, 8, 16. So if I add those, that is 21, so it works. So kind of just double checking this and just like kind of making sure it makes some sort of sense, and getting comfortable with it going back and forth, and you'll get better at it as it goes. Like I said, like I'm not great at it quite yet. I'm a little clunky with it, but hopefully the practice will get you guys there. So our next one here, we get a 1. This next one there's 2, so we have to carry the 1. Here again 2, so we have to carry the 1. Here we actually have 3, so that means we bring down a 1 and bring up a 1. 2, carry the 1. 2, carry the 1. 2, so bring the 1 over. So again, I'm going to write this out. This would be 128 over here, I think. So this is 3 plus 8 plus 16 plus 64. So did you guys get this was 91? Did I do that wrong? Did anyone do it by? Yeah. Okay. And then the second one is 2 plus 4 plus 8 plus 32. So that's 46. So that should be 137, I hope. So I get 1 plus 8 plus 128. Yeah, so we get 137 for both of those. So kind of just trying to see how they convert back and forth, and maybe realizing that adding with binary is like kind of crazy quick as long as you're comfortable with converting back and forth. So maybe that's part of it too, that a computer could add those very easily. They're turning lights on and off as they go there. All right, so just a little mini lesson there. And again, tomorrow I'm going to do the same with you guys. I do have exam schedules for you guys as well, if you'd like those. These are, I think these times are correct. They might just be, if they're a minute or two off, I might be wrong about this. But this is for next Thursday and Friday. The only thing is, I have it kind of listed weird on one of those. So let me just show you guys that, and then I'll get you guys the worksheet. So when I printed this out for you guys, let me show it this way. That look better. All right, so when I printed this out, it's basically, we have our exam. So our exam is here. The hour before is study time if you're behind on stuff, or if you just want to come in. So our exam next week, Thursday, is until 9:20, and unless I request you or your third hour teacher requests you, you don't have to come till 9:20. Then we have AR like normal, lunch, and then our exam 3. And then after that, there's another study session, but on like that sheet, I have like 4th hour written, and that's not correct. So there's another study session. So there's exams here and here. And then the next day, so this is 1st and 3rd, and then 2nd and 4th are the following day. So all the other times are well, not AR and lunch, but they're kind of optional. So there is an exam schedule there on the salmon colored sheet. And so if you have your work in, you shouldn't have to come in for it. But you're welcome to. Oh yeah, 2 math finals in one day.
Yep.
That's why I'm glad that like I have math and then chemistry, so then I don't get the.
Oh yeah, because like Jolie has. You don't have AP Chem right now, do you?
Uh-uh.
Oh, because yeah, like
I have
Jolie
AP
has.
Chem. I don't have AP Chem.
Oh, yeah. Because she's like counting down the moments, like she's like.
Yesterday was our last day of new material.
Oh,
so we were
you guys were like celebrating.
Yeah.
Nice. And she's like, "Can you help?" And I was like, "I haven't taken chem since my sophomore year of high school, so it's like 25 years ago. So no, like that